Okay, so we're deciding if each of these is truly a function or not. So when you're deciding if a relation is a function, what has to be happening with the x's?
They can't be the same.
Okay, they can't be the same. They can't repeat. So on a graph, how do you tell what can't touch it twice? A line. Okay, what kind of a line? Vertical lines. Yes. Okay, so everybody's looking up here. Does that graph pass the vertical line test? No. So is it a function? No. It touches twice, meaning those x's repeat. What about this one?
No.
No, because it keeps hitting it. You're exactly right. It hits it everywhere. Every x is the same. On a vertical line, every x is the same. So vertical lines are not functions. What about this guy? Is it hitting just one time? Yeah, so it's a function. Okay, now on a mapping, you can't just focus on the numbers. What else do you have to look at? The arrows, the 2 lines. So do all of these x's just have one arrow leaving it?
Yes.
Yeah, so it's a function. What about this one? No, because that last one has 2 going away from it, meaning that one is repeating itself. So that's a repeating x. On a table, just find the x's, check them out. Any of them doubled up or anything? So it is a function. That's how you decide. Check out the x's. None of them can repeat. If it's a graph, do the vertical line test. And that's every line can only touch once. Any questions on those? Okay, I would keep that blue paper handy. I've been letting you use them on notes and stuff, and it's got a lot of vocabulary on there, so it'll come in handy as we move along with our functions. So today, we're going to focus mainly on domain and range a little bit. We're going to look at some specific types of domain and range. So will you title today, please, discrete and continuous functions. Okay, discrete and continuous. So these are 2 different types of functions we need to know about and how to find their domain and range. This is similar to last year, so hopefully these words are kind of sounding familiar to you. Discrete and continuous. Let's talk about each of them. We need to understand what they are, what that means. Okay, so just remember from yesterday, we know a function is a relation that's going to pair each input. Is your input x's or y's? Y. Which is it? The one that goes in, which is it? X. Yeah, it's going to relate an x, every input with exactly one output. Put the x's in and out come the y's. So that means if I put in 2 and out comes a 12, next time I put in 2, a function will still give me 12. It won't give me a different number, just exactly one answer. So a function will do that. That's why the x's can't repeat, because we'll get different y's. Now, we talked about domain and range yesterday. Domain is all the x's in a set. Range is all the y's. So remember, D comes before on the alphabet, X comes before Y in the alphabet, so D goes with X. Hopefully we can keep those straight. So we're going to look at these today with our 2 types of domain. Now, discrete and continuous is only, it only depends on the domain. So when we talk discrete and continuous, we're only focusing on the x's. Let's talk about what they are. When you write discrete, I need you to write down a definition. So discrete domain, so it's only the x's that determine this. Will you please write down, it's a domain, so the x's, that represents specific, countable, whole things, like pencils, calculators, bells, people. It's a domain that represents things that are whole, that you can count. That's how you know a domain is discrete. So if your x's are representing pencils, and bars, they start out whole, anything that's whole, then you know that's a discrete domain. It often says a number of shoes or a number of backpacks, whatever that might be. Now on a graph, a discrete domain will show up like this, where the points are just graphed alone and not connected. So will you put a little note by this? On a graph, the points are disconnected. The points are disconnected. So discrete and disconnected. Are disconnected. That's how you'll know if you're looking at a graph, you automatically know if the points are separate, specific points, and not connected, they're disconnected. That's a discrete domain. If you know the function in words, if they don't give you a graph, you focus on what the x's represent. If it's something that's whole or countable, that's going to be discrete. Burritos come whole when you buy them or make them. Yeah, you can cut them in half, but they start whole. And so that would be a discrete domain. So anything whole, countable is discrete. So no fractions, no decimals. So then if we're talking about things that are fractions or decimals, that is a continuous. So will you please write down next, continuous domain. Here's a domain, the x's, that represent all values, including the decimals, not just the whole things. So it'll represent things that can be a fraction or a part of. So that's usually something you can measure. I would be sure to write that down because that helps us think about what we need. It's usually something that can be measured, like height, weight, distance, speed, temperature, time, all those things that you can measure that can be a decimal, then that's considered a continuous domain. You can have values between the wholes, 1.2, 7.85, anything like that. So on a graph, it'll be connected because we're talking about all the x's from 0 to 5. 0, 0.1, 0.12, 0.13, everything from 0 to 5 on that one. So make a note by this, on a graph, the points are connected. So continuous, connected, discrete, disconnected. That's how you know if you look at a graph, even if you don't even know what the x's represent, if they're connected, you know they're talking about something continuous, something that can be a decimal or a fraction. And that's most of the time something you can measure with a measuring device. Height, weight, speed, distance, time, all that stuff. So if you just know, not a graph, but you know in words, your domain, look at what the x's represent. This one's height, and that can be a decimal. You're not just 5 foot usually. Some people might be, maybe 5 foot 2 inches, 5 foot 5 inches. You can have varied heights. Okay, so that's discrete and continuous. Discrete, not connected, continuous, connected. So we need to know how to find the domain of both. We pretty much already found domain yesterday of discrete. All of your graphs that you saw yesterday were just the dots, and you had to write down those points for the x's and y's. So this assignment today, as you were talking, is half and half. The first half we're going to do together on a worksheet. This is how I want you to learn how to do these kinds. And then the second half is a small Alex portion that you are going to try on your own. So the first half, I expect everyone to do it because when we're done, I'm going to come around and check off that you did it to get the credit for the first half of the assignment. And then you'll do the Alex portion and submit the work for that on Canvas. So this is just a way that we can learn together how to do it. And then you will practice just a few on your own to get the hang of it. Okay, so you need to put your name on this. It's the 11th today. I'm going to put the date. I like 7. And a couple of them are like yesterday's. Okay, so this starts out with ordered pairs, much like yesterday's assignment. Okay, so put your name on it, please. Okay, and the first one, we're finding domain and range. And I want you to tell me if it's a function or not. So look at these first set of ordered pairs. What do you have to look at to decide if it's a function? The x's. And where do you find an x in an ordered pair, first or second? First one. So look at those first ones. Is this first set of ordered pairs a function? Yeah, none of the x's repeat, so put a yes by that. Now we're going to write down the domain and range, just like you did yesterday with just ordered pairs or a table or a mapping or whatever. You've got to put them in squiggly brackets. all the x values for the domain. So you told me the x's are the first one, so everybody tell me, what's our first x and go along? What do we have? 6, 7, -7,
0,
and 0. The x's are your domain. The range is the y's. We know that's got to be the second number, so everybody tell me all the second numbers and put them in your range. What do we have?
-3, 4, -2.
And we got another -2, which you don't have to write again. If you forget and do, it's really not going to tell you. It's okay. Okay, look at the second set of ordered pairs. Is it a function?
No.
No, how come?
X is repeat.
Yeah, the x repeats. That's a vertical line because they're all 7s. That's one of the vertical lines. But we could still write the domain and range. So the domains, it's the x's, and they're all 7. So you can just put it once. But the range, tell me all the y's.
1,
1,
-3, 4.
thank you, Kim, for doing that. 1, -3, and 4. Okay, so ordered pairs, you get to put the specific x's in your domain, the specific y's in your range. Those are discrete because they're just certain points. Now let's start with the graphs. Our first one, is that a discrete or continuous domain? Discrete, because it's not connected. It's just discrete. It's just like the ordered pairs, but they're on your graph. So I mentioned yesterday, it's not a bad idea to write the ordered pairs if you want to. This is not required by any means, but it's a method for you to see all the x's and y's right plain in front of your eyeballs, just like the ordered pairs were on 1 and 2. So if you like to do that, it only takes a second, and then you find the domain and range just the same. You get all the x's and put them in the domain, all the y's and put them in the range. So let's just start over here on the left and kind of just go around the circle. Tell me all the x's. -3 and -2. Everybody tell me, please, not just count, everybody.
2,
Everybody, 2,
3,
3, and 1. I just need to hear so I know you're getting the x's. So please, I ask you to please say them. The range, tell me all the y's that go in the range. Starting over here again. 0, what else? 2, and good, -2. We don't have to put the repeaters. We got a second 2 and a second 0. You don't have to put them. If you accidentally do, I think it's going to be all right. Okay, so discrete, you put the specific x's, the whole numbers, as part of your domain for x's, range for y's. Now, is this next graph discrete or continuous domain? It is continuous because it connects one to the other. Now, my domain, I'm supposed to write all the x's down. But if this includes all the decimals from here to here, there's no way I can list them all. There's a gazillion decimals between -3 and 2. So to do this, we are going to use our inequality notation. You write up your inequality notation. Now we actually already know how to do this, because does this kind of look like our compound ands when we're in between?
Yeah.
Yeah, this looks like it's just tilted up, but it's much like an and compound where we're going to go in between our 2 points. So let's talk about this. Our domain, is that your x's or your y's? X's. So to find a domain on a graph, you gotta look left to right, because that's your x. Your x is on the left to right. So we put a little note above domain, but look left to right. That's how you're gonna figure out what you're in between. You gotta look left to right. You just told me they were x's. So remember, when we did this, we put our x in between. We're gonna do that with the graph. It's the same idea. So automatically put your x in the middle. And I would do this today when you're doing it on Alex, so you enter it in correctly. I would write it on your paper so you get the right thing. You'll still use less than's. These are solid, so you do need the equal to on them. And then left to right is going to put us smallest number to biggest, which we need on this, smallest to biggest. So come to the left. This is the very first point on the left. What is the x value right here? -3. So we're going from -3 and then we're traveling over and we stop right here. What's the x value right there? 2. Yeah, so the x's, they go from -3 to +2 on that little piece of line. -3 to +2. Is everybody okay so far? So you have to look left to right for x's. Now let's talk about range. What is the range, x's or y's? Y's. So now you kind of have to make your brain think differently a little bit. Switch gears. Y's is an up-down motion. So you still want to put the y right in the middle, just like you do with the x for domain. Now range is the y's. You still use less than or equal to because we're still solid. But now you got to focus and now think, okay, bottom to top. So I need you to write a little note by your range. Look, bottom to top. Still need to go smallest to biggest on your inequality. So you got to go bottom to top. The lowest point to the highest point. So when you're thinking about range, you got to go bottom to top. It's an up, down, y. So the lowest point on this is this guy. What's the y value for this guy? 1. So that's my first y. And then I'm going to go all the way to the highest point, which is this one. What's my y value right there? 5. So the y's go from 1 to 5. Lowest to highest. Any questions so far? Okay, so if your graph has 2 ends, you're going to always write an in between. An in between. So look at the next one. This is an in between, even though it curves, that's okay. It's still an end and an end. It's an in between. So I just wanted to point out something to you on Alex. If you notice on number 4, I wrote the range first and then the domain. They do that to you. So I wanted you to pay attention. You got to put the domain where it says domain and the range where it says range. They don't always put domain first and then the range. So pay attention to that when you're on the Alex. You got to put them in the right spot. So let's just start with domain. On ours, is the domain x's or y's? X's. And it's a between because we've got 2 ends. So put it in the middle. Still use less than, but look at our left side. It's open. So I can't put an equal to, but what about the right side? You can. So you got to pay attention to that. This left side was open, the right side's closed. Then domain, you got to go left to right, smallest to biggest. So take a look. This is our first left point. What's the x value right there? 0. Yeah, the x is 0 right there. And as I come to the right, stop right here. What's the x value right there? 5, yeah. It's 5. So make yourself find the x. It's always on the x-axis. Just look down. You're on 0. And then you're on 5. From 0 to 5. Okay, range. That's got to be the y's. Now you got to make your brain look bottom to top. Lowest to highest. Lowest to highest. So look, our lowest point is right here. The lowest y is right here, and it starts with 0. So put your y in the middle. I would always do that, just so we get it in the right order. Lowest to highest. So my lowest is a solid. So I'm going to put the equal to there. And Cam's right, it's on 0. Now we got to go to the highest. It goes past there. I'm going to go up till my graph stops. It stops right here. What's the highest y value? See that? It's on 4. And it's solid through there. There's not an open circle right there. So that one's also equal to for the range. The y's, you go lowest point to the highest point. So you got to re-look at it. Different direction. Lowest to high. Are we okay so far on that? Okay, look at the next one. Here we got an ellipse, an oval shape. They do end. We end here, bottom, top. They do have endings, so it is an in-between. Even though it says circle, that's the ellipse, it's okay. Let's start with that domain. Is that your x or y's? X, so automatically put an x in the middle. Your less than's Do you see any open spots in here? No, so they're all equal to, there's no open circle anywhere. They're equal to. Domain, if it's the X, what direction are we looking?
Left to right.
Good, left to right. So we start over here on the left. What's your leftmost X? -3. -3. You're looking on the X-axis. Traveling over to the right, what's your furthest right X? On 5, yes? Everybody see that? From -3 over to 5. Okay, now range, you gotta make your brain. Now look the other direction. It's a Y, so put your Y in the middle, still equal to because it's solid all the way around. Always lesson, lesson. You gotta go lowest point to highest point now. We're doing Y's. So what's our lowest Y? Just look at the Y. -3. Good, and we travel up, and what's our highest Y? +3. Yes, you can let the axes help you know where you are. Y's are on the Y, X's are on the X's. Are we okay with that one? Okay, look at the next one. Now this one's a little bit different because it has arrows. It doesn't have an ending at that top there. So just like we did these, where we had an endpoint to an arrow, and we wrote like X is greater than or equal to -2, if you have arrows, you're only going to write one inequality because it's only going one direction. It's not in between a couple things. So let's talk about the domain. Okay, domain, is it X's or Y's? X's, so that's a left-right motion. Look over here on the left. This arrow means it's going to keep going and going and going and going and going left and right and up, obviously. But that U shape is going to keep going left to right. There's going to be no end on the left side. There's going to be no end on the right side. So my X's are going to go forever negative, and they're going to go forever positive. So guess what my domain is? If I go forever negative, all the negatives, all the positives. How would we? If we're doing all negatives, all positives, infinity. And so we say all real numbers are part of your domain. Those arrows going left and right, I know they feel like they just go up, but they are going left and right as well. That U shape will continue up left and continue up right. All numbers are part of the domain. Like a straight line with arrows, keep going left, keep going right, all the numbers. Now let's look at range though. The range. Do I have a bottom ending? Yeah, I actually do. So I'm gonna need an in-between. No, I'm not, I lied to you. I just told you, arrows will do one. We'll do one, but it's Y. And then from here, are we going up or down? We're going up, so everything's greater than, it is equal to, because we're solid. What's the Y value there at the starting? 0. That's our range. If you have an end to arrows, we use 1. And it'll go from that bottom point. Okay, let's look at some more to get that into our brain. Okay, here's the next one. See how it's got an end to an arrow? You're only going to be using one inequality to describe that. Let's start with domain. Domain is your X's or Y's. X's, so start with X. And we come to the starting point. We want to see where we're starting from. We need the X right there. What's the X of this point? -4. Are we going greater than -4 or less than -4? Greater than. Is it equal to? Yeah, it's solid. So all my X's go from -4 forever. So I say all my X's are greater than or equal to -4. Left to right. Now range, if it's Y's, which way do you look?
Okay.
Good, bottom to top. It's a Y. Start at the bottom. What's our Y value there? 2. So we're going greater than or equal to 2 because it's going up. Most of these are going to be greater than or equal to. I haven't seen one on the assignment yet that goes down. So it's greater than or equal to 2. Only one inequality when you got an end with an arrow. It's going to keep going. It won't end on the other side. We're not going between. Okay, these are really what you're going to see today on your portion of the assignment. The situation doesn't really matter a ton. You could read it, but it's just asking you to find the domain and range of the graph from this situation. So save you some time maybe. Now looking at this one, we do have 2 ends. So you'll want to do an in-between. There's no arrow. So we got to do an in-betweener. Let's start with domain. What am I putting in the middle, X or Y? X, automatically. Less than, are they equal to? Look at your ends, are they equal to? Yeah, they're equal to. Right, don't you get them all? This is part of what you've got to check off today. You should have to practice them all. Okay, so domain, if it's X, we're looking left to right. Come to the left, and we're looking at the X values. You can look at the X values. What's my X value right here? What is it? Everybody tell me.
0.
It's 0. Okay, traveling over to the right, I need the X value right here. What is it? 180. So these X's go from 0 to 180. 0 to 180. So make yourself look at the X numbers. Then range. Now make your brain switch and look bottom to top now. So your Y has to go in the middle. It'll still be less than equal to. They're still solids. Look at the bottom though. What's your bottom Y? Yeah? 450. There it is. 450. Go to the highest point and look at the Y. What is it? 1,350. Are we okay with those? 1,350. Okay, let's look at the next one. Look at the graph. Are we going to do in between or just one inequality? One. Why, Pam? Has the arrow. It's only going from one spot forever the other way. So domain, that's got to be X, and it's going up and right. So is it greater than or less than? Greater than, is it equal to?
Yes.
Yep, it's got solid. Now look at that beginning point. What's your X value?
0.
0. So range, you got to choose the Y for the range. It would be the same. Yeah, exactly right. Greater than or equal to 0. It's also on 0 for the Y. Also on 0. Okay, last one. Are you going in between or just one?
One.
Just one again. That arrow means you're going. So domain, what is it? X greater than or equal to 0, and range? Y greater than or equal to 0. Now be careful though, it might start somewhere beside 0. So watch that. Your X would still be 0, but your Y would be starting from 5. So watch that. Sometimes they're on 0, 0, sometimes they're somewhere else, like the number 9 on yours. So watch that. Okay, so keep this out. I'm going to come around, mark down that you did it. You'll need to get to a clean piece of paper in your notebook to finish it off. Practicing some of these on Alex and a couple like yesterday. So I just need you to title it Discrete and Continuous. That would be awesome. I believe there's only 7. So we've got a good 10, 11 minutes to get them done. Definitely get them done. So today is the 11th. Okay, so I do want to see on your paper, and in fact, it's just helpful just to write it on your paper, so then you know how to enter it into Alex. Sometimes when you start entering it in, you have to enter the 3 first, and then the lesson or equal to, then the X. So it's just helpful you've got to write them anyway. So write them first, and then finish them off. So I'm going to come around and grab the check mark for your portion then on the paper. And then you will just take a picture of the Alex portion and turn that in on Canvas, because I want you to keep, well, you would. Okay, transformations.